Another point of discussion when we're talking about gases and their properties and behaviors is when gases behave as we expect them to and when they don't. So when are gases expected to behave ideally or non-ideally? What would that amount to? This recording will continue on to talk about Earth's atmosphere as well, because it won't be a long one otherwise. So what makes a gas behave as though it is real? When we come back to the ideas in the kinetic molecular theory of gases, the volume of the real gas is determined to be very, very small compared to the spaces between between them. So there's mostly empty space. The volume of the real gas is larger, however, at a high pressure than predicted by the ideal gas law. In other words, low pressure, the volume of the gas particles is negligible on the left here compared to the total volume. When we increase the pressure on the right here, the volume of the gas particles is much more significant compared to the total volume. So at high pressure, the volume of the real gas is larger than the ideal. In other words, what happens here? We're going to have collisions that are different. We're going to have particles closer together, and they might influence one another when they're under high pressure. So you'll have attractions between molecules that can result between the gas particles, and that will also influence the behavior. We assume there are no attractions between gas particles until the pressure is increased. That's typically not going to be an issue. All right, so what else? So what are we thinking about here? The attractive forces between these particles will come up in another chapter. We haven't come to that far in this course, but there are different kinds of attractive forces between gas particles, whether they're atoms or molecules, and as closer they get, there will be some attractions between them. And so molecules will attract one another at distances up to about 10 molecular diameters. So they're going to have to get squeezed together fairly tightly, but high pressure will do that. The other way that they will become closer together is if you cool them down and they become very, very cold, they will nearly want to condense. They will be tending to condense to a liquid. And so that can occur also at very, very low temperatures. So also at low temperatures. An example of that would be like freezing in liquid nitrogen, which is very cold. Liquid nitrogen, we write it out like this, which is silly because it's nitrogen as a liquid. The temperature is 77 Kelvin, and there are some gases that are going to condense to a liquid when you get that cold. So condensing gases will bring them very close in contact with each other, or at least more close enough that they will begin to have attractions for one another, and that is not going to allow them to behave as though they're ideal any longer. There are equations to deal with this, but we're not going to go into that kind of detail. That's left for some more higher level course. Okay, so if you'd like to continue listening to my discussions, this recording will go on to talk about things in the Earth's atmosphere which are not very easily tested, but they're very important topics to consider when we're learning about gases.